My name is Sannidhi Jalukar. I'm a software engineer at Pivotal Labs, which is the consulting side of Pivotal. And I'm currently based out of the Labs Berlin office.
And my name is Madhura Bhave. I'm a developer on the Spring Boot team. Yep. So how many of you, by a show of hands, how many of you use Spring Boot? Wow.
Nice.
And how many of you write tests? And do TDD? OK, so the number kind of dropped down for TDD, but that's fine. So those of you who do TDD will agree with me that TDD is a great way to develop your applications, to drive out the design of your applications. But a lot of times when you do TDD, you might find yourselves in a situation where you're like that, because it's not always easy to write tests for the feature that you're testing. Sometimes it's easier to just go ahead and write the code instead of writing the test, and then you forget about the test, and your code is untested. And Sannidhi is actually going to talk to us. She's worked with a lot of clients with Pivotal Labs, so she knows a lot of the obstacles that they come across with TDD.
Yeah, so one of the most common ones I've seen is like, where do you start? You know, you're writing a test, and what should I actually be testing? Like, for example, the most common one is like a caching test, right? If you're testing caching, do I test the caching implementation? Do I test the behavior? How does my test look like? Or testing complex scenarios like testing databases, or if you have remote services, if they're not up, well, how do I test these scenarios? And another one is, how many integration tests should I have? Should I have all integration tests because my app is very complicated, I can't do with unit test? And what should be the level of these tests in your application? So hopefully we'll try to answer some of these in our talk today.
Yeah, and as some of you might know, Spring Boot 1.4, it came with a lot of testing improvements. We had a lot of new annotations that were introduced to help you write tests for your Spring Boot application without having to start up your entire Spring context for things that you didn't want the entire context for. So we are going to actually be doing live coding, and we're going to do like a Pivotal Lab style pair programming thing.
So there are different ways to pair. One of the most popular ones is ping pong pairing, where one person starts with the test, and the other person does the most minimal thing to make that test pass. And then that person writes the test, and then the other one writes the code, and so on. There are other types of pairing, Driver Navigator, and you can check them out. But today we are going to be trying to do ping pong pairing. So we'll start with an integration. Sorry, yeah. We'll start with an integration test first. You might have seen there are two different approaches when it comes to testing. There is the top-down approach, which we'll be using today, which means we start with an integration level test, and we write a failing test, and we specify what kind of feature we are expecting towards the end of this. And we'll have that failing until we actually implement all the features. And the bottom up, you will start with like a small unit level testing and have an integration test towards the end. Both of them have their advantages or disadvantages. One of the things that I've seen, because we also do continuous integration, is that if you have an integration test, maybe you can't check it into your CI pipeline, because then it'll be red until you actually finish building out the entire feature, and you might want to do small commits and push frequently, so the pipeline will be red for a longer time. Whereas if you do a bottom-up approach, you might be testing really small core components, but when everything is complete, you might see that
the components don't fit well together.
Yeah,
so
yeah.
That's one of the cons of the bottom-up testing. So today we're going to be doing top-down testing. But if bottom-up works for your situation, that's also another way of test driving your application. So we're going to start with an integration test. The app that we'll be building is a car application. So we're going to ask for a car with a name, and it's going to return the details of the car. So that's basically the app that we're going to test. So because it's an integration test, as you can see, we're using the Spring Boot test annotation with a web environment of a random port. So we are building a web application, and for an integration test, we want the server to be running. So we're going to use the web environment random port, which will start up the server on a random port. You can also run Spring Boot test with a defined port. So you can define the port that the app should start up on, or you can say web environment equal to none. So it won't start up the web environment at all. As you can see, we're running with the Spring Runner, which is an alias for the Spring JUnit runner. I mean, I can't remember the name, right? So obviously, using Spring Runner is a more concise way of saying the same thing. It's just an alias for the Spring JUnit 4 runner.
OK.
So with the Spring Boot test, if you can just show them the auto-wired test rest template.
Yeah.
With the Spring Boot test, you get the test rest template for free. So you can auto-wire that and use that in your tests to make requests to your server. The test rest template is basically, it's a wrapper around your regular REST template, but it gives you some additional conveniences, such as you can add basic auth headers to it if you want to make a request which requires authentication, et cetera.
Yeah, and do you want to talk about the assertion that we're using? You're using the assert.j library. It comes for free when you use the Spring Boot starter test dependency, and I highly recommend it. It's very fluent, it's very readable. If there is one thing that you go back and do, use the assert.j annotation, assert.j assertion library instead of the JUnit assertions. OK, so we see that we want to make sure that we have a status OK. Maybe what else do we need in our behavior? We have a body. Maybe we want to make sure our response has a name.
So yeah, so as you can see, the test is actually driving out our domain object here. We don't yet have the name on the car, but the requirement is that when we get the car, one of the things in the response body should, for the car details should be the name, and the other thing that we want is the type. So now because our test is telling us that we don't have the name or the type, we can go and add that to our car object.
Yeah, so as you saw, there was nothing in our car object. We started building it out. And as I forgot to mention that, but there is like a arranged act assert, and I think most of the people in the room have been doing testing, but when I started doing TDD 5-6 years ago, it was very hard for me to like, where do I start from? And this kind of structuring helped a lot because you'll always have an act and an assert. Arrange is just how, if you have extra setup, you could add that there. But the first thing that I do, I'm not worrying about annotations. I'm not worrying about what are the tools I'm going to have, but what am I testing? What is the behavior? What do I care about? Which is the essence of act, right? So I care that this, let me just move this down. I care that there is a URL, which looks like that, which returns a car, and that's the essence of this test. We won't be doing arrange act assert going forward, but we thought it'll be useful for the first test. All right, so let's run our test.
We can actually change the name of our test to reflect
yes.
what sometimes pairing is useful.
Most of the time.
Yeah, most of the time.
All right, so maybe like a car returns car details. OK. And yeah, we have a 404 as we expected. Because we don't have anything. We don't have that endpoint yet.
So that's a high-level integration test that's sort of describing the behavior of our endpoint. OK. And we're getting a 404 because we don't have a controller that can handle this request. So before I add the controller, of course, this is TDD. So I'm going to go and add a test for the controller. And we're not just relying on the integration test, because since we're loading the entire Spring application context, because we use the Spring Boot test annotation, the integration test usually will be the happy path test to make sure that everything in the app is working fine. But the controller test will be more focused towards just the controller. So in that, you can write things like, what if the car was not found, or some other corner cases, which you might not have to write in your integration test.
Yeah, so we'll be using the same runner that we used initially, which is useful if you're running a JUnit test. And we have a web MVC test annotation, which does not start your entire Spring Boot application. It will just wire up the components that are necessary for a web MVC test in this case. So it's going to look for a controller, and it's going to wire up the component. If you have a lot of components, a lot of controllers, then you can also specify the name of the class that you want to wire up. So for example, we are making sure that we have a car controller. Of course, we don't have that class yet, so it's going to complain, but we have to make sure that we have a car controller being available to us when we are running that test. Okay, so we will also, once we finish this test, we'll see that it also failed with the same exception. Because it is a web MVC test, we will get a mock MVC for free, so we will use that, and we'll make the request similar to how we made it in the integration test. The only difference being that this is going to test it directly with the controller, as opposed to the integration test actually starting the Spring Boot application. So this looks very, very similar. We're going to have a status, which is, yeah.
Yeah, we just assert that it's an OK, and then in the response body, we can use the JSON path request matcher to say that the name contains Prius, which is what we've specified, and the type contains hybrid.
Cool. So I think we have everything we need. Yeah.
OK. Yeah, so just the important thing here is we're using the web MVC test slice and a mock MVC. So it's not going to start up a real server like we had with the Spring Boot test. Instead, we're going to use mock MVC to directly test the controller. Running the test should still give us the 404 because we haven't implemented it. So as you can see, it's a 404.
Yeah, and we also saw that we don't have a large application here, so the test run times are relatively smaller. You can't see the difference, but generally these tests will be much faster as compared to a Spring Boot test where you're starting the whole application. Okay, so now what is the simplest thing we have to do to make this test pass, right? We have a 404 and we don't need a 404. So let's go to the car controller. We have to make sure that it is a REST controller because that's how it will know to find it on the path. Otherwise, it will keep going, giving us a 404 because it's not going to find a Spring component on the class path. All right, and we don't have that URL yet, so, and there was a name. We return a car.
Yeah, so this is just a basic controller that we need to add that's going to make our test go green. So for every failure that we get, we do the minimal thing that makes the next assertion go green. So right now our controller it can handle the request, but it's returning a null. So instead of the 404, you should see the next assertion fail, which is the JSON path. It says it's a null pointer because there's nothing in the response body.
Right, and because this is slice test, we are only testing the controller component and we don't care about the other dependencies. So we are going to add a new dependency. We are going to use the test to inject a dependency into our controller, but we are going to be mocking it. So I'm going to use the BDD Mockito given when then style here. So if we have something like
let's say the controller is going to use a service layer to give us the details for the car, we can create a mock bean for that service in this controller test. And it's easy to get a mock using just the @mockBean annotation. And we don't have the car service class yet, so we can go ahead and create that.
And maybe there'll be like a get car details. And we don't care what the name of the car is, so
we can just use any string and say that when you call get car details on your car service, it will return some car.
Yeah, and just
but we don't know how the car service is going to give us the car in the future, so right now it's just returning a null.
Right. Oh, we don't have a, I forgot to make the constructor initially. Okay, so going back, now if you run the test, it should still fail, but sort of our test is now telling us how our implementation will look like. So it's still failing with the same reason. So let's go and use our car service here, because, all right, so get car details. We don't have that yet, so let's inject it.
And that should hopefully give us a
yes.
green test if we've done things right.
Okay, cool. So as Madhura initially mentioned, because we have a slice test, we have the liberty to define other behavior that our controller should have. So for example, get car, maybe if it's not found, what happens when that happens?
Yeah, so you can test corner. Typically, you would test corner cases like this in your slice tests or your unit tests, because those are faster than starting up your entire application. So let's just say that when we call get car details on our service, we get a car not found exception. And in that case, the controller will give us a 404.
I've been doing Kotlin for the last 6 months, so I'm totally skipping on all the news every single time I do this. Okay. We want it to be a runtime exception. All right, so our assertion will look similar. It's just that instead of it being okay, all we care about is that we should have a not found response. Not found response, so all right. I think this should be good to have a failing test.
So it fails because instead of returning a 404, it's actually throwing the exception that the service throws. So this, we get a car not found exception instead of a proper 404 error.
Do you like to pong?
Okay. Right. So for that, we can add an exception handler in our controller, which we can define a response status on that. So we can say the response status for our exception is an HTTP status not found. And this is going to be a car not found handler.
And because we have made it so that our service is throwing the car not exception, it's a good idea to use the exception handler, but the other way to do it is also if the exception is thrown in the web component, you can have the response status not found in the exception class itself, and you don't have to have an exception handler. It'll do the magic automatically.
Yeah, so if your controller was throwing this exception, you could have just, instead of having an exception handler, just added a response status here, and that would have worked too.
Cool.
So if we run this test now, we should get a 404, sorry, a green test.
Green test. All right.
Cool.
Cool. So what's next? We have a service which does not do anything. Maybe we should.
Yeah, so our controller is good. The controller tests are green, but at this point, if we run the integration test, it's still going to fail because the service is doing nothing. For a get car details, it's returning null. So we need to go ahead and write a test for our service.
Mm-hmm. And this is going to be a very, very lightweight unit test. So we are going to try to not even involve Spring in this test because we are testing a very thin slice, right? It's just talking to the controller. We are going to test very basic interactions between the repository and the car controller. And the fastest test that you're going to have is the one that you're not involving Spring at all. And we'll talk about how many of these unit Spring tests you can have and how many of the actual unit level tests you can have or that we prefer to have in our application and the number of integration tests towards the end of the talk. But for now, this is like a different type of test. We are running with a Mockito JUnit runner, as you can see. So it helps us, we don't have to do the init mock if you have used the old style of creating a mock. We don't have to define explicitly. We can just add an @mock annotation on the dependency, and it would know which mock it needs to return. So as you can see, it's different from the mock bean annotation because there is no Spring context, so it's just a mock. Yeah, so there's a car repository, but we don't have a class yet. So maybe we should create a car repository.
Yeah, so the service is like an intermediate layer between the controller and the repository. So the service will fetch the car details from this thing called the car repository. We don't know what it's going to do yet, but we're just going to use a mock in this service test. And we're going to inject it into the car service, which we haven't done yet. So we can go and add that to the car service and add it as a field. And then we've pre-populated the service tests just because they're basically doing the same thing where if you call get car details with a car name, the assertions are the same. It's going to give you a car with a name and a type. The difference is here we've mocked the car repository. So when we say find by name on the car repository, it will return some car. And that leads us to add this method in the car repository, which returns a car with a name. And for now, it will just return null.
Yeah, yeah, we just pre-populated because we thought this was probably not the most interesting part. We are going to move to the repository test next. And yeah, we think that'll be very interesting to actually go step by step. And we think, yeah, this one is very straightforward.
Yeah, so we just added this test as an example of a pure unit test where we're not involving Spring at all. It's basically just using the regular Mockito JUnit runner instead of the Spring runner.
Cool. So does it fail now?
Yeah, it'll fail because we are not using the car repository. So if I do that. Is it red? Okay. So it's red. Expected car not found exception.
Mm-hmm. So we are not throwing that yet. Okay, I can make that pass.
Okay.
Yeah. Oh, right, we're not throwing this.
So again, since this is a pure unit test, it's really fast. You can test your corner cases for the service. So the happy case is that you do get a car back from the repository, and the failure case is that the car is not found, and the service will now throw the car not found exception.
Okay, so this should make this pass.
Cool.
Cool. All right, so let's go to the interesting slice now, to the car repository. As you can see right now, it does not do anything. We just have whatever the default implementation that IntelliJ suggested, and we can start adding a test for that. The car repository test is, I think, one of the most interesting tests because I've seen that there is a lot of Spring magic. I'm not on the Spring team, so sometimes there's so many annotations it could get overwhelming. And testing a repository layer helps me. You'll see that it fails at every stage. It has fast failures. We'll have fast feedback. And it helps me really understand how some of the magic behind these Spring annotations work.
And we're going to use a JPA repository. So we're going to use the data JPA test slice from Spring Boot. So that will just load the context which has the JPA components, and it will auto-wire, give us the ability to auto-wire the repository. But it won't load any of the other web components that the web MVC test was doing.
Try. Okay, so we need the repository. I'll have to auto-wire this.
So this test, we're actually going to add one line at a time so that you can see why we need to add. So for Hibernate and JPA, we need to add like a few annotations here and there, some things in the POM. And I've seen a lot of people just like copy paste a bunch of annotations without knowing what those annotations are actually doing. So we'll go step by step so we can see what causes the failure if that annotation is not present.
Yeah. Okay, so we have a data.
Pull that up.
We have a data access exception because we have used the data JPA, right? So it doesn't.
Oh, sorry. Oh, I was just going to say we don't have Spring data on our class path. So in our POM, we can go ahead and add Spring Boot starter data, JPA.
Found it. Okay.
Spring Boot starter
Sorry,
data.
the Wi-Fi is.
Oh, it's actually a different artifact ID.
Okay. So now we have the next failure because it's like car repository. I have no idea what that is because we have tried to auto-wire it. And if you see our car repository, yeah, it's just a plain class. It doesn't know. So one of the first things that we want to do is maybe start using the CRUD repository now that we have our data JPA dependency. So
yeah, so we can actually make it a Spring data repository by extending the CRUD repository interface from Spring data, and it'll just automatically give us most of the, well, here we just have find by name. So we don't have to actually implement it. Spring data gives us that for free. We have, the dependency should be in the POM should be Spring Boot starter. I can change it. Spring Boot starter data JPA.
Starter JPA?
Spring Boot.
Oh, man. This one?
Yep.
Always pair. Okay. So now if you go back to our car repository, it should know what this is. No.
Did you refresh the Maven projects?
We could try that. Then we have been warned that the network is flaky and it might not. Download the sources quickly. Yeah. It's up to date. Let's go back. Okay. We'll give it a second. And we'll just change this into an interface because we know that we are going to have find by name for free, so we'll just use that. There was a toggle.
Yeah, maybe change it to switch the offline mode off. This one. No, the other one.
Okay.
So yeah, I think it's having some trouble refreshing our Maven cache.
Let's look at our POM again. That looks correct.
If you toggle, did you toggle the offline mode? That one, the one next to it.
Yeah.
Yeah.
And let's try to reload again. Interesting. Okay.
Sorry, what was that? Yes, I think so.
Yeah.
We should have this dependency cache, though, so that part's confusing.
Yeah.
Let me see something.
Sure. Okay, so I can talk about what's going to happen next and use your imagination a little bit while we try to fix this. So we're going to use the CRUD repository, and we are going to have find by name for free. We're writing a test for find by name, and I know like in TDD we say that every single line of code has to be tested, and I think that's just a side effect that you get for free, that every single line of your code is tested because you're test driving it. But it's not about testing each line. It's about making sure that every line of behavior is tested. So maybe you can argue that find by name is something that you're getting from the CRUD repository for free, and maybe you don't have to test it. And that's absolutely OK, because then you might be testing the framework. It's also OK to test your assumptions about the framework in that case. Making sure that the wiring works correctly, if the caching annotation is on the application. It doesn't matter what you're really trying to test in the framework. In this case, we are going to be testing the get by name, but there is a hidden side effect to that, and that's what we want to show once we get this working.
Yeah, I'm not really sure what's going on.
I have it committed. Should I just pull it up?
OK, yeah, let's do that. It's not able to get the dependency.
OK.
Yeah, I don't know why we were brave enough to live code, but.
OK. You sure? We wanna...
Yeah,
okay.
Might as well.
Shortcuts. OK.
Well, I mean, I guess if we don't have the dependency, even the committed code wouldn't have it. But what is anyone else having network issues? You did have it, OK.
Yeah, we were warned that we might have to start tap dancing, but neither of us.
We didn't practice, so. Anyway, so did you talk about the transactional data JPA?
No, we should talk about that.
So, right, if we did have the data JPA dependency, we could have used the CRUD repository from Spring Data. And in the test, we'll just show you what the test is doing. So because we're using the data JPA test slice, we get this thing called the test entity manager, which we can auto-wire in that test. And the reason why we're using the test entity manager here, instead of just doing like a repository.save directly, is because the test entity manager will actually take your first level cache and flush it to the database. So if you were just doing a save and then you use your repository to do a find by name, you aren't really testing the behavior that would happen in a real application, because you were just like saving it in the first level cache. It wasn't getting flushed to the database, and then the find by name was getting it from the first level cache. But if you use the test entity manager and you use the persist, flush, and find method on the test entity manager, what that does is it will actually send an insert to the database, and the find will get the object from the database and recreate it. So as many of you might already know, for Hibernate and JPA, you need a default constructor in your entity class, right? So if we didn't use the test entity manager here, we wouldn't have realized that we need the default constructor, because we wouldn't actually be fetching from the database and reconstructing that object. So that's one way to get a fast failure. We would have caught it in our integration test, but with the test entity manager, you can actually test such things in your data JPA test itself.
Yeah, it's especially useful. Right now, we just have a find by name, but it's very useful when you have some complex queries in your repository, because it's not going to fail in your unit test, and you might see different behaviors when it's actually deployed to production if you don't have an integration test. And that can be prevented if you always use entity manager. I have actually personally, in the beginning, I started using save, and I did not know it was actually not flushing to the database. So it's just the cache that you're testing, not really the database integration. OK, so.
Yeah, so unfortunately, we won't be able to show you the step-by-step failures. So the failures that you would have seen if we had the CRUD repository, we would have needed to add the entity annotation on our car. We need an ID, because it says that it doesn't have an ID, so you see that failure. And then if you don't have a generated value for your ID, or if you don't have a constructor where you supply the ID, you see a failure that ID must be given a value. So that's why we've added the generated value annotation. And the default constructor is, because if you don't do that, when you do the find and Hibernate tries to reconstruct that object, it needs the default constructor.
Cool. What was after that? Let's try caching. Yeah. Caching is an interesting. So because we are not, I'm just going to move over to the caching test, and we are going to show how we would test it. So one of the first things that we have to know while writing a caching test is that we cannot have a unit level test for caching, unfortunately, because caching uses the enable caching annotation that you can see on our application class, which will only be loaded when you're actually starting up the application. So you have to have a Spring Boot test for it, but we don't care about, we don't really need a real server, so we can say the web environment is none, because we are not testing against a server. We just need an application startup, which will detect that there is an enable caching annotation on the application. Yeah, so if you look at, I was talking in the beginning that we want to test the behavior of caching and not how it caches really. So we just have a very simple example where we call the getCarDetails method once, and we call it again. And then we just make sure that the repository is actually called only once, because say if you're updating the details about the car, like you're changing the name of Prius or changing the type, you want that to be cached for some reason, because if it's a car dealer application, you might not update the type of Prius that often, probably. You would want to verify that the car repository, you're not hitting the database every single time, right? That's the main advantage of using caching. One of the other things that you could do if you have a very large application and you don't want to start the entire application from scratch, because that's what this will do. The Spring Boot will configure all the beans which are there in the application, all the component beans. In that case, what we could do is you can use a configuration class and have the enable.
You can just have your enable caching annotation on a configuration class instead of your Spring Boot application, and just make Spring Boot test import that configuration class, and then you can get the caching auto configuration. so that you get the cache manager bean that the caching auto configuration would give you. So in a case where you, like she said before, if you have a ton of configuration in your application and you just want to focus on the caching test, you can separate it out into its own configuration class and load the caching auto configuration.
Right. So this will only load this class, and it'll be a much faster test if you have a large application and you're seeing that this is the slower test. Cool. Anything interesting in caching that we missed?
As you can see here, we've used this annotation called the auto-configure test database. So the reason why we're using that is because our integration test later, if we were doing our live coding demo, we would have tested the integration test against a real MySQL database. And because the caching test doesn't really need to focus on what database we're using in the background, the auto-configure test database will use an embedded database. So you can actually mix and match these Spring Boot test annotations that you have. So this is an actual Spring Boot test, which will load the entire Spring context, but using an embedded database. So you can mix and match the annotations as you see fit for your situation to make your test faster or to suit your situation. Show the cache?
Yeah, sure. Like how we implemented caching.
How we implement?
Yes. Thank you. Like if our test was failing, we would have added that. But, all right. So this is already, we're just using a simple cache, which is an embedded Spring cache. You could actually switch it out for Redis, and your application, your test shouldn't fail. That's the advantage, that you're testing behavior of a cache and not really the cache itself.
Yeah, so we've actually noticed some people when they think they're testing caching, what they test is, oh, does my method have this annotation? They get the annotation on the method, and they just check for the presence of that annotation. So they're not actually testing the behavior of the application, that the thing that they have put the annotation on is caching it. They're just testing that the annotation is present. So
is this what you wanted to? Which repositories? Let me open up POM.
Yeah, we have the data, Spring Boot data JPA starter.
Try JPA repository interface. Extend that instead of the repository.
Okay. In the repository. I don't think we have any of the Spring Data dependencies. It hasn't fetched it for some reason.
I'm just going to turn it on and off again.
Yeah. It was there? Yeah, it was there in the dependencies. It's Spring Data, it's Spring Boot Starter Data JPA should give you.
Let's add a bunch of. Oh, they warned us against using a snapshot. Okay.
Well, we weren't using the snapshot. We were using M7, but.
Yeah, this one. Maybe we can use a different version. Yeah.
I think we can just continue. We'll just,
we'll come back to it.
Is everyone okay if we just show the code instead of the live coding? Yes.
Database tests. I'm assuming you would not have a rollback after the test ran. So if you're in the test twice, you would have written 2 rows.
For the caching one?
No, for the DB test.
For the data JPA test, it has a rollback at the end.
Oh, it does? Okay.
Yeah. The data JPA test is transactional.
Okay.
Yeah, so it rolls back at the end.
Yeah, if you're using a save, you would have to do a delete all in your after. All right. Yeah.
Sure. So what that does is it says that I want to cache the result of this method, and it's going to create a cache with this name that we've specified. So the name of the cache is going to be cars, and I think by default it uses Simple Cache Manager. In Spring Boot, for Spring Boot testing, if you're using like slice tests and you're combining the different annotations yourself, and you have caching enabled, you can also add on the auto-configured cache, I think that's the annotation. So that will configure a no-op cache manager for you. So you won't see your test fail on cache manager not found.
Yeah. Okay, we also have a different set of tests that we want to show you. We also changed the existing application into a reactive one so that we have the same context, and we also wanted to go over that with you.
Yeah, before that, does anyone have any questions so far? Yeah, so for profiles, you can put your properties for the profiles with like a dash. So if you have a profile of, say, test, you can put it in application-test.yaml. Are you talking about that?
Like there was a config class we created, right?
Yeah.
What if there is a being of the same name in the actual application and test?
So you can set a property to tell which profile you want to enable. So if you're using Spring Boot Test, I can show you here. If you're using, let's say,
The caching test.
or the integration test, Spring Boot Test has this thing called properties. So there you can set the active profile property, and then it'll use that profile and load that configuration. Does anyone else have any other question?
I have a question. I thought test rest template was deprecated.
No, it's not.
Okay, well, this morning it showed me it was deprecated. I tried to use it. Maybe that's Spring Boot 2 or something.
We are on Spring Boot 2. I hope we are on Spring Boot 2 snapshots. I don't even know the dependencies at the moment. Yeah, but no, it's not deprecated. You should get it with the Spring Boot test if you have Spring MVC on your class path.
So, do you have any tips how to test the transactions are working correctly?
Not in this repo, but Sannidhi has another repo which she's added at the end of in our slide deck, which she's written her custom query, I think, and a test for that. So we can share the code with you at the end.
Yeah, there is also a few I've used a RabbitMQ in that application, so if you're interested in seeing how I've tested the queues, I'm also going to add a commit which I have locally, which it's useful for testing the async behavior of a queue, because you can use awaitility and other libraries that will like tell you to wait until something is done, even for your synchronous applications. If you're using the new reactive framework, you get a lot of that for free, which we'll be looking at in a couple of minutes.
Do you load some test data before test starts?
So for the data JPA test, yeah, we did have to do the test entity manager persist because it's using an embedded database. To test the find by name, we have the persistent flush has saved the car. H2. So we have H2 on our class path. It'll use the embedded database that's on your class path.
Yeah, because we have used the data JPA annotation, but because we don't have that annotation on our integration test, it will be actually testing with the MySQL, because that's the database which is on the application properties. So if we look at our application properties, we have specified that our data source is MySQL, and only that integration test will be using that. Everything else will be using H2.
If you have a series of sequels, you can run the test sensitive data for the test.
A series of, yeah, so I think you can put an import.sql script, and if you have a Spring Boot test, it will import that SQL and use that data that is in that script.
You have a very large application context, like you said, you can kind of decompose that. Do you
you have these web slices now that allow you to test smaller pieces of individual portions of it, should you break down, like kind of decompose your application configuration to kind of match those same slices?
No, so we haven't explicitly created the beans in a configuration class. If you can see, we've used, so the question was, do you break down your application's configuration to match the test slices? We've just added the REST controller annotation on our controller, or the service annotation on our service. So we haven't explicitly like put them in any configuration class. Spring application has a filter. So if it sees that it's an MVC test, it will filter out all the components that it thinks are not necessary. Maybe we can talk after, I'm not sure.
I have a question more on the JPA test. That's also considered a test slice, right?
Yeah.
So that should also do the same type of filtering?
Yeah, so it won't load your controllers. So data JPA test won't load your controllers or your controller advice.
Sorry, no, JSON test, not JPA. The at JSON?
Yeah, that's also a slice, yeah.
Yes.
Okay, so I think we can move on and see. We have a similar application, but it's instead of Spring MVC, it's written using Spring Webflux, and we'll just walk through how we've tested that.
Okay, so the application is the same that you're already familiar with. It just a car application and gets a car. The tests are also going to look very similar, even though it's going to be a reactive application. So as you can see, we are still using the Spring Boot test annotation, the Spring Runner. Instead of a test REST template, we are going to be using a web test client. We have a reactive Mongo operations instead of the repository that we had, the JPA repository, because Mongo allows us to have non-blocking calls, whereas the JPA still makes blocking calls. So we are going to be using Mongo for this application. This is set up just to make sure that we actually save our car before we are testing the database. There is something in our database, as we talked about initially. And this looks the same. The only difference is, as I said, we are using a web test client.
Yeah, so the web test client is interesting because it's an actual client. So unlike mock MVC, which can be used to just test your controller directly, web test client can be used to test against a real server. So that's one of the advantages of a web test client.
Yeah, and don't we use the same one here? But
Yeah.
this one is special. Yeah.
We use the web test client. So this is just the controller test again. So this test is geared towards your reactive controller. If we just take a quick look at the controller, the difference is that instead of a car, it's returning a mono of car. So a mono is a publisher from the reactive streams, from the project reactor project. It's an implementation of the publisher from reactive streams. And the test is a web flux test. So instead of a web MVC test, it's actually a web flux test for testing your Spring Web Flux components. And in this case, we're still using the web test client. So it's the same API, but it's not going to be against a real server. It's going to test your controller directly. So you can use the same API against a real server or just to test your controller directly.
Yeah, and if you look at the car repository, we were getting a mono because the car repository is returning a mono. And the test for the car repository actually does not look very different from the original one. The only difference being instead of the data JPA test, we are going to use the data Mongo test. And the other interesting bit is the step verifier, which is like a declarative way of creating verifiable steps. So what this is doing is basically it's creating a publisher. We are saying that what are we testing? If you think about the arrange, act, assert model again, the publisher is our car repository. If you can see, car repository.find name is the one that we are testing, and whenever we get the result from it, we are going to test the same, the name and the type. And the other interesting part is that there is a verify complete on this. There is also a verify. The verify complete also makes sure that the complete signal is received. It will keep going until it gets the verify complete signal. The other types of signals that it might stop at is either get a complete signal, an error, or cancel signal. The interesting part here, just to note, is that if you don't have a timeout set, it is going to keep waiting until we get a complete signal. So if you want to make sure that your repository gets this data in a certain amount of time, it would be advisable to put a timeout on this test. Yeah.
Yeah, so step verifier is actually from the reactor project.
Yeah. Actually, this thing is fine. It knows where the CRUD repository is. It looks like it wanted us to do the reactive live.
I think we said too many times that the JPA test was interesting, and that's why it didn't work for us.
Okay. All right. So, so we have a cheat sheet which is committed in our GitHub repo. So you can take a look at it. We have thrown all the annotations that we have used in our demo. I use it myself sometimes just to look up what a certain thing does. If you are, you can obviously go into the Spring docs and read more about it, but if you are writing a test, it's a good place to look it up. I can just open that and show you. It's just it's just a list of the annotations that we've used and a very short description of what you can use it for. And the last thing we want to talk about is, we have seen the traditional testing pyramid, and this is our interpretation of how Spring comes in the middle. So there are unit tests, and we saw a service test that we wrote was purely a unit level test. We did not involve Spring at all in the test. It was super fast. However, there are certain unit level tests that you do want to involve Spring. For example, there was the controller test where we were getting the mock MVC for free, and we actually cared about what endpoint are we going to hit. Just testing it on a unit level without involving Spring would probably not make sense. And actually,
so in the Spring world, just what we saw, the Spring Boot test over here fits in the integration test. For unit tests that also involve Spring, so you can use the slices that Spring Boot gives you, the web MVC test, the web flux test, and the data JPA test, the data Mongo test. There are a few other slices, so you can refer to the documentation for that. And for the unit tests, there's absolutely no Spring involved, so we just ran with the Mockito runner and used the @mock annotation. Yeah, from the pyramid, you can tell that you should write more unit tests, and then some tests that use unit tests and involve Spring, because a lot of times you do have to involve Spring.
But the slice test, basically.
But the slice tests, yes. And then at the very top, you should have some integration tests to make sure that everything works well together.
Comes together correctly, yeah.
So you don't have to feel like you're drowning. There are tools to help you out, and TDD shouldn't always be hard as people think it is. So thank you. And the repo with the code, both the reactive and the non-reactive code, is up on GitHub at that. And those are our Twitter handles. So if you have any questions, feel free to ask us either on Twitter or after this talk. Thank you.
Thank you.